But before we talk about what a system is, we're going to talk about a new formula, right? We've been using y is equal to mx plus b, our slope-intercept form, quite a bit. Now we're going to introduce something called standard form. May look a little bit different, but it's not too bad. Standard form looks like this. AX, capital A, plus BY, capital B, equals capital C. AX plus BY equals capital C. Now in this standard form here, A, B, and C are all going to be what we call constants. And a constant is just another word for a number. Whereas X and Y are going to be variables or letters. We've actually seen standard form before in today's warm-up. But instead of having x and y as variables, we had a couple of numbers written inside parentheses. It's the same setup, same format. That's kind of what we're going to be working with here. So that's our standard form. A system of equations is just, let's see, what can we say here? We can say two linear equations that work together, that are grouped together. Two or more linear equations that are grouped together and related somehow. We'll go more in depth as to how they're related as we move through this unit, but just in the most basic sense of the term, that's what a system of equations is. Here's an example of what a system of equations looks like in standard form. Yeah. going to give you guys a little bit of time to write this because I know it's a lot of writing. Question, Ross? Yeah. And ordered pair. So our lesson title was finding the solution to a system. We've got our standard form down. We've got a definition of what a system of equations is and what that looks like. The last thing we have to identify is what a solution is, which is just an ordered pair, x comma y, also known as a point's coordinates. An ordered pair that makes a true statement when plugged into an equation. It's going to be a lot all at once because it's kind of a new topic to us. So I understand if it doesn't make a whole lot of sense at first. There's a lot of layers that we got to peel back and understand. So for today's work, it'll be pretty light. Don't worry. So this is going to kind of be like the Matho that we played a week and a half ago, where we plugged in a bunch of numbers into a bunch of variables and solved it out. The difference is here, instead of looking for what B is equal to, we're going to be looking for a true statement or a false statement. It's pretty easy to tell what statement is true and what statement is false. A true statement would look something like 4 is equal to 4. A false statement would be something like 4 is equal to, anyone want to fill in this blank? 9, 8, 6, 2. We'll go with 9, right? Is 4 equal to 9? No, definitely not. That's right. So 4 is equal to 4. That's definitely true. 4 is equal to 4. If I have 4 homework assignments and you have 4 homework assignments, we have an equal number of assignments. But if I have 4 homework assignments and you have 9 homework assignments, that is not an equal number. That would be false. So hopefully we see the difference here between a true statement and a false statement, because that's what we're going to be looking for on worksheet 27. Pretty easy to tell whether an ordered pair is a solution or not. All you got to do is plug the x coordinate in for x, the y coordinate in for y, and solve using our good old friend from elementary school, PEMDAS, just like we did in our warm-up. That's why it was a warm-up. This is going to be more confusing in writing than it will be in the actual math, so just stay with me here. If you get a true statement, it is a solution. And naturally, if you get a false statement, it is not a solution. So that's what we're looking for. True statements and false statements. If you plug in your x and y, solve it out using PEMDAS, and you get something like 4 is equal to 4, you know that that ordered pair is a solution. If you plug in your x and y, solve it out using PEMDAS, and you get something like 4 is equal to 9, that's a false statement. You know it is not a solution to that equation. Now, one way we can think about this, that I like to think about it at least, is equations are like ovens, okay? Where if you put something into an oven, the oven's gonna work its magic, do its thing, and you're gonna get some result out, right? If I put cake mix into an oven and wait half an hour, what am I gonna get out? Sure. If I put cake mix in a pan, put it into an oven, wait half an hour, what am I gonna get out? Cake, right? We put something in, we got something slightly different out. And cake mix is, of course, something that goes into an oven, right? So we could say that cake mix is a solution to the oven. But what's something that doesn't go in an oven? I'm trying to think.
Wait, what?
A fork.
Baby.
Ice cream. Wait, what?
Okay.
What happened?
That's a good one. Ice cream, right?
Wait, what?
So maybe take that out and you'll hear. So cake mix, right? You put it in the oven, it comes out as cake. That works. But if you put ice cream in an oven, it comes out as just
Melty.
hot melted ice cream. That's not really something that you want. Maybe it is. If it is, I mean,
It was just being
seek help. But maybe it is. But most likely not, right? So that wouldn't really work out. Ice cream is not something that would go into an oven. That's a great example. Daisy, did you have one?
You can't put a baby in an oven.
Oh,
That is true. You also don't want to do that. It's not going to get
but you can't do it.
you. Well, okay. Well, then we can we're parsing definitions here of what you can do and what you should do. You definitely should not do that. This example's going off the rails. Does that make a tiny bit of sense, maybe? Okay. Equations are like ovens. They serve a certain function, but only specific things work when you put them in. That makes sense, right?
Yeah.
A little bit? Okay. Let's just do an example. That might make even more sense than these long, convoluted analogies here. Let's try and figure out, is the ordered pair 2, 4 a solution to the equation (5x minus 2y equals 2. So it's an equation in standard form. Ax plus by equals c. Well, in this case, ax minus by equals c, where a, b, and c are all numbers or constants, and x and y are just variables or letters. So we're asked a very specific question. Is 2 comma 4 a solution to the equation and that equation there? Yeah. Yeah, when Brooklyn goes back. Sure. So is this point a solution to the equation? How am I going to figure this out? Well, if we take one flip back, to determine if an ordered pair is a solution or not, plug x in for x, plug y in for y, and solve it out. Then we'll look to see if we have a true statement or not. So in this ordered pair of 2 comma 4, which number is my x coordinate? 2 or 4? 2? How do we know that 2 is my x coordinate? Because it goes first, right? If you sing the alphabet to yourself in your head, not out loud, you sing the alphabet to yourself, you're going to get to x before you get to y. So my first point 2, my first coordinate is my x coordinate. My second coordinate 4, that's going to be my y coordinate. So 4 is going to get plugged in for y. 2 is going to get plugged in for x. So that'll look like 5 times 2 minus 2 times 4 equals 2. Hey, that looks just like our warm-up, aside from that 2 on the right. This was what we did in our warm-up. We multiplied, and then added or subtracted our products. Nothing different. The only thing that we're adding on to that is figuring out where my x goes and where my y goes. Because if you flip them around, if you plug in y for x and x for y, you're going to get a very different answer. It's going to switch up whether you have a true statement or a false statement. That's not what we want. So now we go through and we solve. Let's go ahead and multiply both of these together. What is 5 times 2 going to give us?
10.
10. 5 times 2 gives us 10. What is 2 times 4 going to give us over here? 8. Bring down the minus. Bring down the equals 2. All right, just drop that minus down. Now we're going to subtract. What's 10 minus 8? 2. And we get the statement 2 is equal to 2. Is that a true statement or a false statement? True. 2 is equal to 2 is true. That is a true statement. So this is a solution. Hopefully that process is not too bad. Give me a thumbs up if you follow what we did there. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Ooh, only 10. Maybe some of us are still writing. That's okay too. We'll do another example here. Take it breezy. I'm going to move this down a bit. Let's do another example. And then we'll get started. Is the point -2, -3 a solution to the equation to x plus 4y equals 6. We'll move this down here. Hopefully we've got that. There's our equation in standard form.
I haven't been standard form in so long.
I know. Have you guys learned standard form before?
6th grade.
6th grade, really? Wow.
Yeah, 4th grade too.
That was a long time ago. Go ahead, Delaney. Yeah, I already said. Yeah. I got you. I wrote it down. So, in this point, -2, -3, what's my x coordinate? -2 or is it -3? -2 is my x, which means that -3 is my what? Y. So we're going to take out our variables, x and y. We're going to substitute in our x and our y from the point. 2 times -2 plus 4 times -3 is equal to 6. Now, we don't know if that's equal to 6. We've got to multiply, solve it out, and find out. Okay? Give you guys a minute to catch up to that, and we'll go through this process together. All right, let's multiply here. What is 2 times -2 going to give us? -4. Beautiful. What about 4 times -3? -12. We bring down that plus sign. Bring down that equals 6. Now, what happens when we have a plus sign right next to a minus sign here? What does that make? A big plus?
Oh, no, minus.
A big negative sign, right? So this turns into -4 minus 12 equals 6. What would -4 minus 12 be?
Oh. I was looking at.
See 2 minus signs? Think about spending money. How much do you spend in total here?
Negative.
4 plus 12?
Oh, no. Jeez.
-16. If you spend $4, then spend $12, you spent $16. Whenever you see 2 negative numbers, -4, -12, add them up as if they're positive. If I asked you what's 4 plus 12, what would your answer be? 16. So because they're both negative, we just have negative 16. That's all. We gotta subtract there. And we get negative 16 equals 6. Double check to make sure you didn't do anything wrong. We followed those steps perfectly. We were very precise going through this. Is negative 16 equal to negative 6? No. It is not. This is a false statement. So this ordered pair, this singular point, is not a solution. Negative 2 comma negative 3 is our ice cream that when we put into this equation that is our oven, we get something out that we do not want. Warm liquid ice cream. Actually doesn't sound that bad, but not what we want. Now in the first example, right, 2 comma 4, that was our cake batter or our brownie batter, cupcake batter, cookie dough, whatever you want. We plug it into our equation just like an oven, and we get out our cookies or our cake or our brownies. Baked to perfection, that's what we want. Down here, this is our ice cream. We put it in the oven. We do not get something that's appetizing. Appetizing? Yeah, that's the word. At all, it's not what we want. If that analogy is confusing you, forget I said anything. But if it helps, cool, I guess. There's our second example there. All right. So all we're doing here, we're going to work with just one equation at a time today. Tomorrow we're going to build it up to discovering if a certain point is a solution to the system of equations, which is just 2 equations tethered together. We're going to start off slow today.